If you are a data scientist or you are in the journey of becoming one, you would have heard about pandas. Well, not these pandas, but this one. In this video, I'm going to show you everything you need to know about pandas to show up to interviews and job applications with full confidence. And also, personally, I will help you develop all those you need to know about pandas and data wrangling with pandas. Pandas is a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool. As you may be aware, in a data scientist's life, data manipulation plays a very important role and is one of the steps that takes a lot of time. The name pandas has a reference to panel data or tabular data, like a table, and also from probably Python data analysis. And it was developed by Wes McKinney in 2008, so it's already 14 years old. So like every other package and a library, Pandas has a source code that lives in the GitHub repository. The link is down below. And if you're not sure what a GitHub repository is, check the link up the top right, where I take you through everything you need to know about Git and GitHub. So you might ask, what is Pandas good for? Pandas is really good for data manipulation and analysis. The way Panda does it is super fast and super efficient. In every data scientist, machine learning engineer, or artificial intelligence specialist's life, the data first needs to be prepared for the model building, and you can't just simply use raw data as it comes from your CSV, from your Excel file, and just dump it into the model. What I use Pandas for: read and write data. Data cleaning for different reasons. Data exploration and analysis. Before you do any modeling, explore what type of data you're dealing with. Data manipulation, data visualization, and overall data wrangling. If you don't have Anaconda installed on your machine, I have left a link at the top right of this screen. So feel free to pause here, get it installed, and come back to this video. Let's start a Jupyter Lab or Jupyter Notebook session. I prefer using Jupyter Lab because that gives me a lot more functionality than a Jupyter Notebook. And if you haven't seen my video on Jupyter Notebooks, I have left the link on the top right of this screen as well. Let's go and launch a Jupyter Lab instance. Now I am in my Jupyter Lab instance. You can see where I am looking at in my laptop. And I'm just going to go ahead and start a Python 3 notebook. First thing we need to do is import pandas as PD and import NumPy as NP. I will show you more functionality down the road, but for now, I'm just happy to import these two libraries. I have a separate video on NumPy that I'm going to leave the link up the top right. In the series of videos I'm making, I'm also going to show you the best practices in naming conventions and how to keep your projects really tidy. So go ahead and rename this file to 00 pandas intro. This will help us to easily track where we are and what is the next step. I have put the link to every one of these Jupyter notebooks down below in the description, so feel free to download them. One of the fundamental concepts in Pandas is the difference between series and data frames. Series are one-dimensional data, so like the names of my friends. There is no other attribute about that. However, data frames are two-dimensional data. Say, if I was to add my friend's ages, is 43. Now, this is a second attribute. So let's go ahead and make a series from my friends' names. Let's view that. It looks two-dimensional because we have indices. However, the data itself is only Alex, Astrid, Hesam, and Bobby. This was 0, 1, 2, 3 is the index associated with each of them. For example, who is sitting on index 0? Alex. Who is sitting on index 1? Astrid. But I cannot add their ages to the respective names. What I need to do, I have to say, so my df equals pandas data frame, because we're going to deal with two-dimensional data. I'm going to zip friends names to friends ages. Zipping to lists essentially acts like a zip on your clothes, on your jacket. It puts respective values against each other, like a zip. The only thing I don't like about this data frame is that the column names do not really make sense. I would like this column to be called name, and I would like this column to be named age. What I can do in the creation, I can say, okay, I want to give you column names. First column is going to be called name, and the second column is going to be called age. The easier would be to make data frames or series from dictionaries. So let's make a dictionary of the data that we already talked about. So let's call first key name, and I'm just going to input my friends' names, and then age to be friends' ages. So new data frame equals pandas data frame, a data frame from my dictionary. So let's view that. You can see that automatically name and age get assigned to the column names and the values go into the table. One of the biggest powers of Pandas is in reading text files and allowing you to do different types of data wrangling on them. Excel file that I have put the link down in the description below for you to be able to download. It's a data set that I have downloaded from University of California, Irvine. People's ages, their job, and their education, their marital status, and their salary back in 1996 was more than 50,000 USD or less than 50,000 USD dollars. Before I go ahead, you can see that there is no column names in this data set. I'm going to be reading this into Pandas. I would definitely have to name those columns. Okay, now I'm in my new Jupyter notebook. I have called it 01 read CSV basic QC. I'm just going to go ahead and import Pandas and NumPy. I'm also going to set the number of columns that are going to be displayed and the maximum number of rows that is going to be displayed to none. It means that I will have no limitation whatsoever in the number of columns and rows that I can display in my Jupyter notebook. Here is how we read CSVs. Read the CSV using pandas read underscore CSV, the address, and the name of columns. Where I have the name of columns, I have introduced them here. First and foremost thing that I do when I read a CSV file is just look at data raw and head. Head of the data allows you to see the top 5 rows. You can choose how many rows you want to see. So if you just say data raw head 7, it will show you 7. If you go 100, it will show you 100. You can look at the bottom rows of your data as well. So if you use data raw.tail, that will show you the bottom 5 rows of your data. The next command I almost always use with any data that I read is data raw, or whatever you call your data frame, and dtypes. Dtypes shows the type of parameters you're dealing with. For example, for age, you've got integer 64. For word class, you've got an object. For education, you've got an object. Once you are happy with the dtypes or data types, you can go ahead and look at the info in your data. So what it does, it shows the type of data we're looking at. It's a data frame. The number of entries, 32,561. The number of null values in that column, and the dtypes. It also shows you the data types by their numbers and also the memory usage for this database. Last but not least, let's look at data raw.describe. What it does, it looks at descriptive statistics of the numerical columns. For example, for the column age, the mean value is 38.5. I have opened a new Jupyter notebook called 02 column selection. And here I'm going to show you how to select columns in Pandas. Reading the Pandas and NumPy libraries, reading the database, and then there are 3 ways to choose a column. Your data frame, dot name of the column. If I run this, that will print all the age column. Let me just clear the output. Approach 2, using the lock function. If I wanted you to remember one thing about the lock function, is that it works with labels, the names of the columns. What I'm doing here, my data frame, lock function, I want all rows for column age. If I run it, it will print it all. Let me clear the outputs. Approach 3, using the ilock function. Ilock function works with indices. Again, my data frame, ilock function, all the rows, column 0, because age is in column 0. Working with different data sets, you might have to select multiple columns for some reason. Say, if you were to choose marital status, occupation, and relationship within this data set, and they are sitting on indexes 0, 1, 2, 3, 4, so 5, 6, and 7. I want indexes 5, 6, and 7. And I'll show you 3 different ways to select columns. Approach 1, using the column name. Essentially, all you need to do is to choose the name of the data frame, open double brackets, and I repeat, double square brackets, the name of the columns you want, and close double square bracket. Given that this blows my Jupyter notebook, it is not wise to look at all the data, rather looking at the head of the data. Approach 2, using the ilock function. Ilock function works with indices. The columns I'm interested in are sitting in indices 5, 6, and 7, but I have to say from 5 to 8 because we do not include the last number. So this means 5, 6, and 7. I'm not going to print this. I'm just going to print the head, and you can see that it's exactly the same. Approach 3, using the lock function, and we know that lock function works with labels. So I want all rows, and I want these columns in a list form. So again, let's look at the head because we don't want to print everything, and that's approach 3. In the multiple column section, we chose specific columns, either by label or number. However, we chose all the rows. What would we need to do if we were to choose specific rows, say, for example, rows 100 to 1500? That's very easy. With the iloc function, just mention the number of rows you want and the number of columns you want. We'll see that it will run from number 100 all the way to 1499. I told you it runs to the number before the last. What I will do now, I'll just display the head so that it doesn't really blow up my Jupyter notebook. The second approach is using lock. We know that lock works with labels for columns, and we can specify which number of rows we want. The biggest difference between the lock function and the iloc function in selecting rows is that the lock runs from 100 all the way to 1500 inclusive. However, iloc runs from 100 to 1499. Let's talk about filtering data. Filtering data is essentially trying to cut out a piece of your data, performing analysis and making decisions on it, or just gaining some insight about it. There's a hospital data. There are a lot of people coming in with different health issues, but we are only interested in looking at people who have blood pressure problem. In our current data set, we will be looking at different ways of filtering the data. Let's start by filtering only based on one condition. I just want to look at the data for the female community in this data set. What I will do, just go ahead and say, I'm looking at data raw. Within data raw, I will be looking at the gender column, and I want female values. Let me just call this data female. I just look at the head of data female. You will see that the gender is exclusively only female. Within the female data set, and only select wife population. I'll say, okay, data female, and look at data female column relationship, and I want the data for people who are wives. So, and I'm just going to call it data wife head. You'll see that it is only wife and only female. So this is how you would do it one by one. If we were to do it together, so female and wife in one go, you will be looking at your data raw anyways. We know that the conditions will go into a square bracket, but given that there are two conditions, make parentheses for each of them and leave and between them. Data raw, condition number one is gender should be female. Again, data raw, relationship should be wife. I'm going to call this data female wife. Let's look at the head of the data that we just made, dot head. So that's exactly the same. So once you have a couple of conditions, 2, 3, 10, doesn't matter, you can just add them in between parentheses and with and sign in the middle. This section is really important. You receive some data and there might be a lot of null values. First thing first, you will need to understand why there are null values and also what are you going to do with them. For example, think about some data about school and their students. Every student might have a phone number and email, but not every one of them will necessarily have a Twitter handle. So when you are populating a database about that school, you will have a lot of not given values for those Twitter handles for students that do not have any Twitter account. So what are you going to do? How are you going to deal with that? Are you going to get rid of those students in that school database? Or are you going to put 0 instead of that Twitter handle? What is the best way to go? There are two ways to understand if there are null values in your database. So one of them is going data raw is an A. So this is checking if there is an A, and then you sum them. This will show you the number of null values in each column. So column H has 0 number of null values, and so forth. The second way of checking if there are null values is just simply by looking at dataraw.info. There are 32,561 not null values in the age and all the other columns. And we already know that this database has 32,561 entries, which means no null values at all. For the purposes of this exercise, I want null values because I want to show you how to deal with them. Using these two lines, which you can go ahead and copy that, I am inserting null values randomly in the data raw. So if I do data raw is an A dot sum, I can see that I have introduced almost 3,250 null values to every single column. If I look at data raw.head, you can see that there is a null value here, another null value here. So randomly, I introduced null values to this data. Before anything, let's look at the shape of the data. 32,561 rows. The first and foremost used way of dropping NAs, your data, drop NA, and let's write that to a new container. We don't want to override our data. We want to contain it somewhere else. Let's look at the test shape. 6,581. So almost 26,000 rows are gone. Where have they gone? Well, the way drop NA works looks at every single row. If it sees null values, even one null value will drop that row. And that's how we lost all those rows and are left with 6,581. A lot of functions in programming languages have default values. This is the web page for the official drop NA from Pandas library. So you can see that it has to be a data frame, then you assign drop NA, and the default is axis 0. In Python, axis 0 is always rows, axis 1 is columns. If I go back, what if I wanted to base my drop NA on column? Drop any column that has one or more null values in it. So easily this time I'll say data_raw.dropNA, but perform this on axis 1, which means columns, not axis 0, which is the default and is row. If I perform this, the shape of the test changed to include all the rows, none of the columns. The reason being, I introduced random numbers of null values in this data frame. When drop NA look at this data frame, there were at least one or more null values in every single column. Therefore, drop NA has dropped all of them. A lot of times you will have to group your data. It means that you will want to, without going down a lot of conditioning and filtering, understand what is some general statistics of a specific group. Imagine we wanted to understand the average time every person works in different countries. What would we have to do with that? Let me start that with a simpler example. I have a dictionary, gender, male, male, female, male, female, female, male, their ages, and their income. This is a dummy dictionary. Let's look at that data. So this is the data frame I'm dealing with. Imagine I want to understand how many males and how many females are in this data frame. So easy. So data.group by. What am I grouping by? Well, you asked how many males and how many females. So you get a group by gender. And then look at the size. So there are 3 females and there are 4 males. Could I do that with age? Of course. You have one person who is 12, one person who is 19. With income, you have one person that earns $5,000. Can I do it based on 2 parameters? Of course. You need to make sure you use square brackets because you're going to use a list of column names. Gender, comma, and the next one will be, you have one female who is 12 years old. These numbers are the number of people. You have a male that is 19 years old. Would I be able to do that based on all of them? Yes, that's absurd for this data frame, but of course you can. One female who is earning $5,000 and they are 12 years old. You have another female who is earning $110,000 and they are 52. What if instead of size, I looked at the mean value? It will show me the average age for females, which is 43, and the average age for males, which is 29.5. The average income for females is $50,000 per year. Could I do sum? Yes. So, well, it doesn't really make sense to add people's ages together, but just trying to show you that it is possible. Now that you got the general idea about grouping by, let's just read the data that we have been dealing with so far. Head. This is the data. I'm going to give you an example of grouping by the country of origin, but then you can apply the same rules to any different type of group. Imagine I was interested in understanding the mean or the average values for everything in this data frame for the people in the United States, in Cuba, and all those other countries. So I'm just going to go data raw, group origin, and mean. So Country of origin, the people in Cambodia, their mean age is almost 38. Their education number is 8.7. The average capital loss for a Canadian is 129 on average. For a Chinese is 179.5. After your group by, you can say, here is a list of columns that I am interested. I am interested in age and capital gain. And that's what you're gonna get. Let's talk about the final chapter. Importing the libraries, reading the data. What if I was to plot the age column? Pandas supports a different number of plotting, not really fancy ones, but something that will help you in your exploratory data analysis or EDA, which I'm gonna post a video really soon. Raw. One of the ways of selecting columns is by just dot notation. So data raw dot age dot plot. That simple. So your x-axis is the number of rows and your y-axis is the age. What if I was to plot age against, say, hours per week? Is there a relationship between people's age and the number of hours they work? Plot dot scatter, and you're gonna say, okay, between age per week. And that should give you the scatter plot between age and hours per week. About if I were to understand what is the bar chart of marital status, how many people are married, how many people are never married, select the column, which is marital status, value counts. Let me show you what it looks like. 18,970 people who are married. Go to plot and then take the bar.